In this GIS Pro Tip, let's see how to use two tools in the Spatial Analyst toolbox, Con and Combine. The Con, or Conditional Evaluation tool, allows us to control the output value for each cell in a raster data set based on whether the cell value is evaluated as true or false by a conditional statement. If the cell is evaluated as true, it will receive a value that we specify. If it's evaluated as false, it will receive another. The Combine tool combines multiple rasters so that a unique output value is assigned to each unique combination of values found in the input rasters. Today, I'm working with two land use land cover data products from the National Land Cover Database, or NLCD. The NLCD is produced by the Multi-Resolution Land Characteristics Consortium, which is a group of federal agencies who coordinate and generate consistent and relevant land cover information at the national scale. Here you can see land use land cover information for two time periods, 2006 and 2016, for the state of Kansas. For this quick demonstration, let's zoom into and work only with data for Lyon County, Kansas. Let's run the Con tool first by clicking on the Analysis tab and finding the Tools button in the Geoprocessing group in the ArcGIS Pro ribbon. In the Geoprocessing pane, I'll search for the Con tool and set my first input conditional raster to be the 2006 NLCD data. Next, I'll enter an expression that lets me evaluate whether a cell's land use land cover type is cultivated crops. I'll specify input true and false constant values of 1 and 0 respectively. And before choosing Run, remember, I only want to perform this operation on data for Lyon County. Rather than create a new file for this purpose, I'll take advantage of this tool's environment settings to narrow the processing extent to Lyon County. Now that the conditional evaluation is complete, you can see only zeros and ones in the output. All cells with a value of 1 indicate a true evaluation, or cells that in 2006 were classified as cultivated crops. Cells with a 0 value were some other land use land cover type. Next, let me repeat this process to perform a conditional evaluation of the 2016 data. I could do this all in one step by using the Con tool in batch mode, but I'll save that for a future GIS Pro tip. With the output of the second conditional evaluation complete, let's see if we can detect change in the location and area of cultivated cropland between these 2 years. Between the default color scheme, the size of Lyon County, and what's likely to be a relatively small amount of change, I can't really see any obvious difference between the two outputs. Next, let's use the Combine tool to do this work for us. I'll find the Combine tool again by going to the Analysis tab and clicking on the Tools button in the Geoprocessing group. However, rather than searching for the tool, I know where it's located. So I'll click on Toolboxes in the Geoprocessing pane and find Combine in the local tool set of the Spatial Analyst tools. Starting the tool, I'll input the conditional rasters from 2006 and then 2016, modify the output file name, and then click Run. With the output of the combine tool now in the contents pane, you can see that there are 4 unique values, 1, 2, 3, and 4. But what do these actually mean? To find out, I'll open the attribute table. Now things perhaps make a bit more sense. Given the input conditional rasters, there were 4 possible unique combinations of input values, and each of those combinations are represented here. The first 2 values, 1 and 2, aren't really interesting. They simply reflect where both inputs weren't and were cultivated crops, the 1s and 2s respectively. What's more interesting to me are the remaining 2 values. Cells with a value of 3 indicate a change to cultivated crops, while 4s are a change from cultivated crops to some other land use land cover type. Looking at the count field, I can see there are 30,768 cells that changed to cultivated crops between 2006 and 2016, and 6,098 cells that were cultivated crops in 2006, but something else in 2016. The net change then in cultivated crops is a plus 24,670 cells. Knowing that the pixel resolution of NLCD products is 30 meters or 900 square meters in area, I can quickly estimate that Lyon County saw an increase in cultivated cropland of about 2,220 hectares. The con tool is one that gets frequently used, often in conjunction with multi-criteria decision support or index modeling approaches. Combine, on the other hand, really excels at helping highlight changing raster attributes over time. I hope you found this GIS Pro Tip helpful. For more tips, follow Geography and Geospatial Sciences on Facebook or Twitter. And if you want to learn more, consider taking a GI Science course at K-State or even major in Geographic Information Science and Technology.